Fourth question, the matrix A is there, that value is 5, 3, minus 1, minus 2. Then to show A square minus 3A minus 7I2, that value is equal to 0. A matrix contains all the value becomes 0, then the name of the matrix is a 0 or null matrix, so we write it is a 0 or 0 matrix. Now to show the sum of these three values become a 0. And hence to find the inverse, okay, to find inverse also. There will be two questions. First is to show that value becomes 0 and also to find the inverse of A. So first we verify that, okay. So it's a LHS value, we simplify, we get RHS. So first I will be taking LHS. What is the value of LHS? A square minus 3A minus 7I2. So in LHS, we already have the value of A, it's a given matrix. And you know the value of I2, 1, 0, 0. So the first step to find the value of the matrix A square. So first step to find A square. You know very well, we write A square as A into A. A into A is A square. Now we write the name of the matrix A value. So A into A, the first matrix is A. What is the value of A? The value of A is 5, 3, minus 1, minus 2 into the next matrix is also A. So again we write A. 5, 3, minus 1, minus 2. Now we multiply these two matrices. 5, 5. 5 by 7, 25. 3 into minus 1 is minus 3. Second row, first column. Minus 1 into 5 is minus 5. Minus 2 into minus 1 is a plus 2. Now we will be take first row, second column. 5 3s are 15. Next, 3 into minus 2 is minus 6. Second row, second column. Minus 1 into 3 is minus 3. Minus 2 into minus 2 is plus 4. So the value of A square is 25 minus 3 is 22. 15 minus 6 is 9. Minus 5 plus 2 minus 3. Minus 3 plus 4 is a plus 1. So we find A square. Now we find A square minus 3A minus 7I2. A square minus 3A minus 7I2. First we write the value of this A square. A square values are 22, 9, minus 3. So A square is over. Next, minus 3. Minus 3. A is the given matrix. The given matrix A value is 5, 3, minus 1, minus 2. The next symbol is minus 7I2. So first number minus 7 into I2. What is the value of I2? The value of I2 is 1, 0, 0, 1. 1, 0, 0, 1. So in first matrix no change, we write as it is 22, 9, minus 3, 1. Next, I keep the sign minus outside, but I multiply the number 3 inside. You know the rule, in any matrix outside one number is there, the number is multiplied each and every elements. So I keep the minus sign outside. First of all, I multiply the number 3. 3 5s are 15. 3 3s are 9. I keep the outside minus. I multiply the number 3 only inside. So 3 into minus 1 is minus 3. 3 into minus 2 is minus 6. Here also we do the same work. I keep the minus sign outside. I multiply the number 7 only inside. So 7 ones are 7. 7 into 0, 0. 7 into 0, 0. 7 ones are 7. Now we simplify these 3 matrices. You know the matrix addition and subtraction rule. We add so many matrices and we separate so many matrices. It is possible only when all the matrices have in same order. You see all the 3 matrices are in same order. What is order? Is 2 by 2. And you know the working rule, how to add and how to separate. The corresponding element only added. Corresponding element means in first matrix the first element is 22. The number 22 is added only with the corresponding element of the second matrix and corresponding element of the third matrix. Now in the second matrix the minus sign is also there. The minus is also common in each and every element. So I multiply minus also. So minus 15. Here also I multiply 7 inside, minus 7. So these elements are called the corresponding elements. Now we added the first row, first column element of all the 3 matrices. Next I move the second element. The second element in the first matrix is 9. What is the corresponding element of the second matrix? Is also 9, but the outside one minus sign is there. So it becomes minus 9. Minus 0 is there. So minus 0. So first row over. Next, the same manner second row. In second row, first matrix element is minus 3. Whose corresponding element in the second matrix is also minus 3. But outside one minus sign is there, so minus into minus 3 is plus 3. Here minus 0. Last element, that is second row, second column element of the all the 3 matrices. Plus 1 is there, so we put 1. Next minus 6 is there, but outside also 1 minus. So minus into minus 6 plus 6. Minus into 7 is minus 7. Now we check 22. Minus 15 minus 7 is a minus 22. Plus 22 minus 22. It becomes 0. 9 minus 9 minus 0. 9 minus 9 is 0. 0 minus 0 is also 0. Minus 3 plus 3 is also 0. So it is 0. 1 plus 6 is 7 minus 7. 7 minus 7, it becomes 0. So a matrix contains all the elements are 0. It is called the 0 or a null matrix. So we write it is a 0 also. So a matrix contains all the elements are 0. It is a 0 matrix. So we write we put 0 also. So now we will take LHS. The LHS is a square minus 3a minus 7i2. Become RHS. What is RHS? The RHS is 0. So LHS and RHS both are is equal. Therefore a square minus 3a minus 7i2 it becomes is equal to 0. The RHS. So 0 is the RHS. We will take LHS. Now it will become RHS. Therefore LHS and RHS both are equal. Therefore a square minus 3a minus 7i2 become 0. So here is the proof for the first one. And also in the question, one more is there, that is to find A inverse. So we find a two manner, either using formula of A inverse. What is the formula of A inverse? 1 by determinant A into XII is one working. Or using this result, we find A inverse. Now I simplify this result is A square minus 3a. Suppose this minus 7i2 goes to RHS plus 7i2. Because already is 0 is there in RHS, so we will link. So minus 7i2 become plus 7i2. So we do the two ways to find A inverse in this sum. Either we directly use the formula of A inverse 1 by determinant A into XII, or using this result to find the inverse. So using this result, the first step I will take the RHS of minus 7i2 goes to RHS. Next, we find A inverse. So I post multiplied A inverse on both sides. Post multiply means right hand side. Pre multiply means left hand side. So A square minus 3a into A inverse is equal to 7i2 into A inverse. So I post multiply A inverse on both sides because this is an equation. I multiply the two same matrix in both LHS and RHS, so the value cannot be changed. What is the particular reason to multiply A inverse? We need A inverse. So I postly multiplied A inverse on both sides. Now we see this A inverse is common in both the terms. So I multiply inside. So it becomes A square into A inverse minus 3a into A inverse. Okay, minus 3a into A inverse is equal to 7 I2 into A inverse. That is, I will take outside constant. I multiply the matrices I2 and A inverse. Here A square into A inverse. I write this A square as A into A inverse. Okay, we write this A square as A into A and then A inverse minus 3. You identify what is the value of A and A inverse. Here inverse is the A. So A into A inverse. So A inverse is the inverse of A. We already see the multiplication of one matrix and whose inverse always we get identity. So I2. 7. What is the value of I2 into A inverse? Where I2 is the identity matrix. So we multiply any matrix to identity matrix, we do the same matrix. So the value of I2 into A inverse is A inverse because I2 is the inverse. A inverse is there, so I put A inverse. Suppose B is there, I put B. C is there, I put C because I2 is the identity matrix. Any matrix is multiplied with the identity, we get the same matrix. So 7 A inverse. In RHS, A square A into A into A inverse. You know, in our lower class, we already see matrix multiplication is always associative. Associative means we modify the bracket in any manner. Okay? So A into A inverse. So now I write this is A into A inverse. Because matrix multiplication is associative. That is, we change the brackets in any manner. So I change the bracket A into A inverse minus 3I2 is equal to 7 A inverse. What is the reason to use the matrix associative here? The value of A into A inverse is The value of A into A inverse is identity. So A into I2 minus 3I2 is equal to 7 into A inverse. What is the value of A into I2? I2 is the identity matrix. So A into identity matrix is always A minus 3I2 is equal to 7 into A inverse. Now we write the value of the matrix A. So the value of the matrix A is 5, 3, minus 1, minus 2. Minus 3 of I2. The value of I2 is 1, 0, 0, 1 is equal to 7 into A inverse. Now we separate these two matrices. The separation of these two matrices is possible? Yes, it is possible because the order of both the matrices are same. So we separate the corresponding elements. The first element is 5. The element is separated to the first element is 1, but outside the number minus 3. So I multiply minus 3 directly. So minus 3 into 1 is minus 3. So 5 minus 3. Next 3. Minus 3 into 0 is a minus 0 or plus 0. Next minus 1. Minus 1. Minus 3 into 0 is minus 0. Moving. Minus 2. Minus 3 into minus 1 is a minus 3. Is equal to 7 into A inverse. Now we simplify this matrix. 5 minus 3 is plus 2. 3 minus 0 is 3. Minus 1 minus 0 minus 1. Minus 1 minus 0 minus 1. Minus 2 minus 3 minus 5 is equal to 7 into A inverse. But our question is to find A inverse. So we do one more work. What is the work? What is the next step? We need a alone A inverse, but this A inverse is multiplied with 7. So the multiplication 7 become division. So it becomes 1 by 7 of 2, 3 minus 1 minus 5 is equal to A inverse. So it is a value of A inverse. That is A inverse is, we leave as it is 1 by 7 outside, or sir I multiply 1 by 7 inside. Okay. So I multiply 1 by 7 inside, it become 1 by 7 into 2 is 2 by 7. 1 by 7 into 3 become 3 by 7. 1 by 7 into minus 1 become minus 1 by 7. 1 by 7 into minus 5 minus 5 by 7. So it is a value of A inverse. We keep our 1 by 7 outside, or we multiply 1 by 7 inside. So both are correct. So now we do the second way of to find the A inverse according to our given result. Okay, using this result I find the value of A inverse. Or some more students, sir I finished the work. Next I using the formula to calculate A inverse. This also correct. This also we have the same value. Using this formula, what is the formula of A inverse? The formula of A inverse is 1 by determinant A into adjoint A. So first step to find determinant, and the next step to find adjoint, then we apply, we have the same one. What is the reason to do in this way, sir? Our question is, yes, we find A inverse. So using this result, I find the inverse. Some of the students, sir, I use the formula. According to this formula, I find A inverse, sir. This is also correct. We also the same value of this A inverse. And seventh question. if A matrix value is 3, 2, 7, 5 and the matrix B is -1, -3, 5 and 2. Two matrices is given. To verify AB the whole inverse, you should be read it as AB the whole inverse. It should be is equal to B inverse into A inverse. Now we verify both the values are equal or not. So first step, given matrix A and B. So verification sum, so we take LHS and RHS. First we find the value of LHS. What is the value of LHS? AB the whole inverse. We find AB the whole inverse. What is the formula of A inverse? We already say how to find the inverse of any matrix. What is the formula of A inverse? 1 by determinant A into adjoint A. What is the formula of B inverse? 1 by determinant B into adjoint B. So what is the formula of AB the whole inverse? So whose formula is 1 by determinant AB into adjoint of AB. So first we write the formula. The formula of AB the whole inverse is 1 by determinant AB into adjoint of AB. What is the reason to write the first formula? We find how many terms in AB the whole inverse. So we find first of all 1 by determinant AB and adjoint of AB. If we need a determinant of AB, first we find AB. So first step, to multiply the matrices A and B. Now we multiply the matrix AB. The A matrix values are 3, 2, 7, 5. And the next matrix is B. The value of the matrix B is -1, -3, 5, 2. -1, -3, 5, 2. Now we multiply these two matrix first. 3 into -1, -3. 2 into 5 plus 10. Okay, first row, first column over. Next step, second row, first column. 7 into -1, -7. 5 5s are plus 25. Now first row, second column. 3 into -3, -9. 2 into 2, 2 2s are plus 4. Second row, second column. 7 into -3, -21. 5 2s are plus 10. So the value of AB is -3 plus 10 is plus 7. -9 plus 4 is -5. -7 plus 25 is plus 18. -21 plus 10 is -11. So we find AB. Next we find determinant AB. So determinant AB. We reduce one step also. Directly we find a determinant. So determinant AB. Directly we write the values. So how to find the determinant of this matrix? First we multiply these two elements. 7 into -11, -77. Next we multiply the remaining two elements with a minus. So minus of 18 into -5. 18 into -5 is a -90. -77. Minus into minus is a plus 90. So in shortcut form, directly we find the value of this determinant. So determinant AB is equal to -77 plus 90 is a plus 13. So this determinant AB is over. Next we need adjoint of AB. If we need adjoint of AB, first we need AB. We already find the value of AB. So now we write adjoint AB. So adjoint of AB. We know the working rule how to find the adjoint of any 2 by 2 matrix. What is the value of AB? Is that. Now we find adjoint of this matrix. What is the first working rule? We interchange the leading diagonal elements. So what are the leading diagonal elements here? 7 and minus 11. We interchange. So it becomes minus 11, 7. The next step, change the sign of the remaining 2 elements. Minus 5 plus 18. So this minus 5 become plus 5 and plus 18 become minus 18. So it is a value of adjoint AB. Now we use this 2 value in AB the whole inverse. So AB the whole inverse is, the formula of AB the whole inverse is 1 by determinant AB into adjoint of AB. So 1 by determinant AB, the value of determinant AB is 13. And then adjoint of AB is value is there. So 1 by 13 into adjoint AB minus 11, 5, minus 18, 7. So I put it is equation 1. You see I keep 1 by 13 outside. Is enough. Is the value of AB the whole inverse. Now we check the same value is also will come in the RHS also. What is RHS? The RHS is whose reverse? B inverse into R inverse. So I put it is equation 1. Now we find the value of RHS. What is RHS? The RHS is B inverse into A inverse. That is the RHS is the product of 2 inverse. One is a B inverse and another one is A inverse. What is the formula of B inverse? The formula of B inverse is 1 by determinant B into adjoint B. So we need determinant B and adjoint B. So first we find determinant B. So determinant symbol B. The value of the matrix B is minus 1, minus 3, 5, 2 is the value of the matrix B. So determinant symbol. Whose values are minus 2. We multiply these 2 elements with a minus sign. So 5 into minus 3 is a minus 15. We put one minus sign. So minus into minus is plus. So plus 15. So determinant B value is plus 13. So in B inverse we need first of all determinant B. Next to find adjoint B. Determinant B over. Next to find adjoint B. Adjoint B. Adjoint of the matrix B. The matrix B value is minus 1, minus 3, 5, 2. The first step, we interchange the leading diagonal elements. So the leading diagonal elements are interchanged. So it becomes 2, minus 1. And the next step is change the sign of the remaining 2 elements. Minus 3 is there, so it becomes plus 3. Plus 5 is there, it becomes minus 5. Next step, to write the formula of B inverse. The formula of B inverse is 1 by determinant B into adjoint B. So 1 by the value of the determinant B is, we already find that value is 30 into adjoint B. The adjoint B matrix value is 2, 3, minus 5, minus 1. So it is a value of B inverse. Also to find A inverse. In A inverse we need determinant A into adjoint A. So the first step to find determinant A. A matrix you know already. Directly we find the determinant. First we multiply the leading diagonal elements. So the leading diagonal elements 3, 5, 7, 15. Then we put one minus sign. We multiply the remaining 2 elements. What are the remaining 2 elements? 7, 2. 7, 2 are 14. So determinant A value is just 1. Next, to find adjoint of A. Adjoint A. Because in A inverse formula is 1 by determinant A into adjoint A. So adjoint A. Do the same work. We interchange the leading diagonal elements. So the leading diagonal elements are 3, 5 is there. So it becomes 5, 3. Next two elements, sign only change. So sign, both are plus. So minus 2, minus 7. Now we apply these two value in A inverse. So A inverse. Formula is 1 by determinant A into adjoint A. 1 by, what is the value of a determinant A? The value of a determinant A is also just 1. 1 into adjoint A. Adjoint A value is 5 minus 2 minus 7, 3. 5 minus 2 minus 7, 3. So A inverse is, we know very well, 1 by 1 is just 1. We multiply inside, we have the same value. So A inverse is 5 minus 2 minus 7 and 3. Now we multiply these two matrices A, B inverse and A inverse. Because RHS is B inverse and A inverse. So first matrix is B inverse and the next matrix is A inverse. The value of B inverse is 1 by 13 of 2, 3, minus 5, minus 1 is the value of B inverse. And what is the next matrix? A inverse. The value of A inverse is 5, minus 2, minus 7 and 3. Now we multiply these two matrices. Outside one scalar, 1 by 13 is there. So we keep 1 by 13 as it is. We multiply these two matrices. 2, 5. 2 5s are 10. Minus 3 into minus 7. So minus 21. Next, minus 5 into plus 5 is minus 25. And minus and minuses, plus 1 7s are 7. Now first row and second column. 2 into minus 2, minus 4. 3 3s are 9, plus 9. Next, second row, second column. Minus 5 into minus 2 is a plus 10. Minus 1 into 3 is a minus 3. So B inverse into A inverse is 1 by 13 of, okay, this 1 by 13 of 10 minus 21 is a minus 11. Minus 4 plus 9 is plus 5. Minus 25 plus 7 is a minus 18. 10 minus 3 is 7. I put it is as equation 2. Now you will see from 1 and 2. You see 1 is the value of 1. The value of AB, the whole inverse, is 1 by 13 of minus 11, 5, minus 18, 7. Now we see 2. B inverse A inverse value is also 1 by 13 of minus 5, minus 11, 5, minus 18, 7. You see the conclusion from 1 and 2. Both have the same value, okay, same number of elements, and outside the scalar 1 by 13 is also common. So from 1 and 2 we get AB the whole inverse, it should be is equal to B inverse into A inverse. Okay students, today we see how to find the adjoint and inverse of a 2 by 2 matrix. I do some sums in the exercise. we practice the same model sum in exercise and example also. You try in your own step, you have no doubt. So I explain how to find adjoint and inverse of a 2 by 2 matrix. Okay, so you must prepare and also you write the same model sum occur in the exercise and example also.